All right, so I do want to talk just briefly on focusing the light on the retina of the eye. So things like close vision, visual accommodation for close vision. The lens is going to change its shape to focus onto the retina. The shape of the lens is going to be controlled, like we said, by the ciliary muscle within the ciliary body. To view a distant object, the ciliary muscle is going to relax, and the muscle is going the muscle is going to relax, and this lens is going to flatten. If we want to view up close, we're going to actually contract this muscle, and it's going to round out the shape of that lens. So to view a nearer object, the ciliary muscle is going to contract, the lens becomes round and thick. Close work requires the constant contraction of that ciliary muscle, so it fatigues. This is what's known as eye strain. It's going to be much more common after the age of 40 because the lens loses its elasticity and is unable to accommodate. You can do things like use eye drops or corrective lenses, eyeglasses or contact lenses to help reduce eye strain. You should also, especially if you're spending a lot of time on the computer or on your phone, you're going to notice that you get quite a bit of eye strain. One, your pupil is dilating constantly. I'm not dilating, constricting constantly to kind of filter out the excess light. But you're also going to be constantly contracting your ciliary muscle to allow you to look up close. This is a common problem. I'm sorry, when we get to the eyes, I'm going to talk about my husband quite a bit just because he has a few homeostatic imbalances that just make life interesting. So I like to talk about it in this class because it gives you some real life examples. So as I said earlier, my husband only has one eye. He lost one due to cancer at a very young age, and his remaining eye is under quite a bit of strain and stress. It's been doing all of the hard work for his vision for the last however many years. Since he was a child. And so because of that, his eye is underneath quite a bit of strain all of the time. He's working on his master's degree in accounting, and so he has to do all of his reading. All of his reading is done with one eye. It's very exhausting. Not only is he uses all of the muscles in order to control that one eye to move back and forth across that page, but he's also reliant on his eye to continually contract in order to read. So his eye fatigues fairly quickly. Now, one sort of blessing, I guess, is that when he was in college, he had a severe bout of glaucoma that came and pressurized his eye, and he had a couple of other problems, and so they ended up having to remove the lens. So they actually removed the lens altogether. So fortunately, his ciliary body isn't constantly focusing or contracting on anything, but he does have to wear pretty strong prescription glasses, pretty strong prescription bifocals, so that way he can see far away and he can see up close. And he can control that by looking up or down. He doesn't need to focus that on his ciliary muscle of contracting and relaxing in order to change the shape of the lens, because his lens has been removed completely. So that's just an interesting thing. So he gets eye strain, but not necessarily from the ciliary muscle, but from the rest of the muscles, which we're going to talk about a little bit later, that control the movement of the eye. So it's the one eye that's constantly moving across the page, left to right. It's very exhausting and fatigues very quickly. So there you go. Some fun information. We're going to talk quite a bit about well, you know what? We'll get to that a little bit later on when we get there. But anyway, he uses eye drops to help reduce that eye strain. He also uses corrective lenses to help sort of to do the hard work of contracting and relaxing the looking of the close versus far vision. All right, as I mentioned earlier, we do have a blind spot in our eye. This is going to be the area where the optic nerve exits the eye. There's no rods or cones in that region. So we have no photoreceptors in that region. It's technically considered a blind spot. Now, two eyes together provide complete vision. The blind spot for the right eye is not the same as the blind spot for the left eye. So if you have two eyes, you have complete and full vision. My husband, only having one eye, does have a blind spot, which of course also contributes to his inability to drive at night, or his difficulties driving at night, because he does have an actual blind spot. Just like you have a blind spot in your car, there's a region that you cannot see that's not covered by the mirrors in your car, your rear view mirrors. So instead you have to check your blind spot when you're making right and left turns. In the same way, your eyeball itself has a blind spot. So that's going to be this region located right here. It's just a small center of your vision that does not have any rods or cones. All right, so this is going to talk just briefly about corrective lenses and how corrective lenses can actually take some of the brunt of the focus on your eye. So if you can see from 20 feet what a normal person with normal vision can see at 20 feet, you're said to have 20/20 vision. If you are nearsighted, it means that you can see close, but you can't really see far away. The eye is going to be elongated and the distance objects are brought into focus in front of the retina. So you're going to actually use a corrective lens to readjust those, that light, and so it actually can readjust it and focus it into the correct spot on your retina. To see distance objects, we can wear concave lenses, which help spread the light rays so that way the image focuses correctly on your eye. So that's nearsightedness. I'm personally nearsighted, so I have to wear corrective lenses. Now, my vision is very, very good for the most part, so it took me a long time to realize I needed glasses, but I have difficulty with things far away, specifically white on green. So I first noticed this in school with chalkboards. I could see black chalkboards, but I could not see the white lines on a green chalkboard. And it's just because there's not enough contrast there to really provide for good vision. So I wear corrective lenses. There you go. And then there's also farsightedness. So with a farsighted individual, they can see far, but they can't see close. The eye is shortened in this case. The actual eyeball itself is a little bit shorter than what it needs to. And so your retina is too close to the lens. Close objects are focused behind the retina. So to see those close objects, you could wear a convex lens. This is going to increase the bending of the light, so that way the image focuses more accurately on the retina. There is also the potential for an astigmatism. Astigmatism is when the cornea or the lens is uneven. It creates sort of a fuzzy image. Now this can be corrected by an uneven lens, a lens that's convex in some areas and concave in others. All right, so you should be able to identify the various structures of the eye and provide the function of each. Focus on that chart. That will be the most helpful to you. You should also be able to describe the two types of photoreceptors and the function of each, and summarize the movement of sensory information from photoreceptors to the visual cortex. Again, we did not spend a whole lot of time on this. It's not going to be a huge part of your homework or your quizzes, but I would like you to at least read over that section in your chapter. Just kind of familiarize yourself with the pathway of light to lens to retina to the brain. So just be a little bit familiar with that pathway. It'll help you going forward and taking other classes. All right, please let me know if you have any questions, comments, or concerns.